Okay, we're live.
All right, let me know when you. I'm already on question 4, so.
Oh, okay. So the true population, that's p hat, isn't it?
Actually, it's just the regular P.
So p hat's the sample mean.
P hat, it just said it is called the point estimate.
The point is, okay.
Yeah. So regular P is the true population proportion, and then P with the pointy is called point estimate.
Better write that down. That sounds like we're going to need that a little bit.
Yeah.
So p hat equals so on the questions that we had to answer, population point estimate is p hat. Okay.
All right, what's up, fellas?
How's it going?
It's going, man. So where you guys at?
Question 4. That's fine. Let's see there. So I've got true for question 4.
And I believe that is right, based on the thing we did last week.
For question 3, we have just the regular P. So that would be C.
C. Okay. All right.
Okay, so for a hypothesis test, trying to find the requirements for that.
Oh.
So hypothesis test, the requirements are the same, it looks like, so it would also be true.
Where'd you see that at? That's in the reading?
Yeah.
Under section 4?
Yeah, I've got, that looks like it's under step 4. and 4.1. So it has to be, oh, wait. Actually, never mind. It's not the same thing. Let's see. But I think it's still going to be true. Yeah, it's still going to be true. So the requirements for conducting a hypothesis test are under 4.1, step 4, and then where did I see the ones for? And then under 2.2.1 is the requirement for the confidence interval.
So we have P over X.
We're on question 6 now? Or are you guys figuring the other one?
Yeah, that's where I'm at now.
Okay.
So then are we supposed to divide the 45 or the 60 from the 45 to make it 0.75? 70, or in other words, 75%?
So
Right? I mean, because it literally just says, estimate the proportion of the first degree defendants who were found guilty. Well, 45 out of 60 were found guilty.
yeah, that's true.
That just seems like normal, regular arithmetic.
Yeah, because it says here that point estimate, which is the P with the little hat,
Yeah, P hat is what it's called.
P hat, is X over N, and I think X is 45 and N is 60. So
Yeah, because I think the sample itself is n, and it always stays n. So yeah, that's what I was thinking too.
Yep.
Yeah, it's just getting you that so you can go back to the 95% confidence interval.
Right.
So now we just got to go back to the 1 minus P times by P.
So, get a 95% confidence interval. So it looks like that's going to be
So then under 2.2, that's the equation then right below where we find P estimate equals X over N. Is that correct?
Yeah, under 2.2. And then I think to find this 95% confidence interval, we do this long equation right here. Where it says P hat minus Z, and then all the...
Right, exactly, yeah.
Yeah.
Okay.
But we got to find the z-score for that, right?
95% is going to be 1.96.
Oh yeah, because it's 95%, huh?
Yeah.
I guess you take the z-score times your answer before you subtracted the p hat. Is that order of operations?
I don't know. I'm gonna. I think so. I'll check their answer here, see how they did it.
I got 0.640.
I got a 0.003.
Well, crap.
So we take the population estimate, right? Is that what it's called? The p hat minus the z-score. I got a negative 1.2, 1.21.
I think you have to do it the other way. I think you take the z-score times.
Oh, I think that's what I missed. Is I didn't multiply. What's the end result? Oh, get back here. Oh no, I did not square root. That's what I did not do. Let me go back. So once we this sample that.
Okay. So yeah, you do. Sorry, I was just checking to see if you.
Which one you did first?
Yeah, which one they did first, and they did do the multiplication first. So just double checking.
No, I'm horrible with those order of operations. So.
Yeah.
So what is it then? What do you have to do first?
Well, 1.96 times that, all that mumbo jumbo. Get that answer, and then do the p minus whatever that is. Order of operations. Let's see. So we need to.
So I'm taking z-score times p, or I'm going through like p times the 1 minus p over n, square rooting it, and then timesing it by the z-score?
Yep.
Yeah, and then you subtract it from the p hat.
Yeah.
Okay. All right. Let me redo this then.
Okay, so I'm gonna do this.
Can we do this in Excel?
I am, but it's a long way, but it works.
So, P 60.
Simple Z test.
So is it asking us to find the upper bound or the lower bound?
It asks for both of them.
Well, eventually, we just got to find what the 95% level is right now, and then we have to add 1.6 or subtract 1.6.
Yeah, well, we're just here. These are giving us the equations to find the upper and lower bound.
I see.
Yeah.
Let's see.
So if you subtracted, then you found the lower bound, and if you add, you find the upper bound.
So then the confidence level must be of 95 would be just flat out 1.96.
No, they're asking for the margin of error in the first one, which once you have the upper bound and lower bound, it's pretty easy to find the margin of error. You just
Find in between, right?
find the difference and divide by 2.
Yeah.
So we can just work backwards. That's fine.
Okay, so square root.
So the first number you found, Alex, was the lower bound, I
This is
believe.
the lower bound. Is that what did you guys get there?
I'm almost there. Let's see.
Yeah, I'm almost there too.
What did I just do? 1.6. Okay, so I'm going to do. So for that one, looks like I have a 0.640.
0.640. Okay, that's what I had.
Okay, good. So that's the answer to question 8.
8. Yeah. Now I need to go back and add it.
Yeah. So just, all right. I've already got it up here.
Oh, do you?
Yeah, I just switched the subtract sign to an addition sign, so that made it a lot easier. And that one came out to 0.85, 0.86. It would be.
0.8. So we need to go to 3 decimal places.
It would be 0.860.
Okay.
Yeah.
So now we can subtract those two.
I got 0.110 for margin of error.
That seems very small.
Yeah, in the example, it's really small too. So I don't know. I don't know why they're small. So
All right. So on 10, I have decrease. Am I thinking about that right? You guys agree?
um, I think so. Let's see. So it's asking confidence interval.
So if you get more of a sample size, your confidence interval should decrease.
I believe that's correct. Yep.
No, number 11, I don't think we ever figured out how to do it. I missed it on the individual homework.
Oh yeah. I still don't know how to do this. Number 11 and 12.
Oh, is it?
Yeah,
I guess we got to figure out how to do it.
I know.
According to the reading, I think there is an Excel sheet you can download we had before.
Oh, you know what? You might be right.
I don't. I followed the link and you can't get it to show up.
Let me see if I can take a stab at it.
There it is. I found it.
You find it?
Yeah. So if you
Nice.
follow the link, it's categorical data analysis.
Categorical data analysis.
Yeah.
Oh, okay. I see it. It says categorical data analysis hat.
Hacked, yeah.
Right.
Okay, let's see what this tells us.
I put our stuff in and it was right. At a 95% confidence interval. P hat was 175, mean 60. So I think
Would it be under one proportion?
11
Connect.
says it is.
Oh yeah, so one proportion. Make sure you're on the one proportion tab.
Mm-hmm.
X would be 45.
Yeah.
wait.
And is confidence is 95.
Wait, if P is 1/2,
So is there a way to do it backwards?
let's see. Actually, I do think it talks about that in the reading. Under 2.2.1. Is it talking about? No, it's talking about hypothesis test. So that would be under section 4.1, step 4. So it has to be n times p, which is half, has to be greater than or equal to 10. So
Where are you at? You're on step 4 of 4.1.
yeah. The following conditions have to be satisfied. NP is greater than or equal to 10.
Uh-huh.
N times 1 minus P is greater than or equal to 10. So those are the only things we have to make sure.
So suppose P.
So are you still using the one sample z-test for proportion? Or you guys pass the one portion spreadsheet?
No, you don't need to use that spreadsheet.
Okay.
The answer is 20. If P equals 1/2, and we have to, NP has to equal 10 at least, it would be 20 times 1/2 equals 10.
So if it was 0.1, it'd have to be 100.
Is that in the reading where you found that?
Yeah, it's under 4.1, step 4.
So do you have 100 on 12?
Yep.
I see.
Actually, let's see. Yeah, 100.
Okay. So eight.
Okay, the conditions for conducting a hypothesis test. 82.6. Yeah, that's good. And then
So did you change the confidence interval to 0.6 and the null hypothesis to 0.6?
No, confidence interval. Wait, what about the I didn't do anything with the confidence. I'm just on question 13.
Oh, okay. I put it into the Excel sheet already.
Oh, gotcha.
So has it met? I think that's true.
Yeah, it is. It's true. X equals 38, n equals 80. Test is less than. Test statistic. Is that p hat for no? Never mind. P hat is 0.475.
Right.
Yeah.
I don't know where test statistic would be. Would Z be the test statistic?
I'm looking right now. I don't think.
I believe it is.
I thought they were one and the same.
That's what I gathered as well. That Z and T are basically the same thing.
So you got a negative 2.282.
Yeah.
And then, wait, for Z you have a what?
Negative 2.282.
Let's see. Oh, I didn't fill in the null hypothesis. Just a second.
Yeah, I changed both the confidence level and the null hypothesis to 60%.
Yeah, that's
Right.
great. Yeah, negative 2.282. And then p-value is 0.011.
What did you get for the p-value?
I got 0.011.
You're at less than.
Yeah, I did less than. I did 38 for X, 80 for N.
Yeah.
Confidence interval 0.95, null hypothesis 0.6. Less than.
Okay. So if that's the case, we reject it. All right.
Yep.
0.05.
So you're rejecting the null. Is equivalent water quality. Is that D?
I don't know on these.
Yeah,
I'll choose D and submit it.
Yeah, I was gonna say I'm not too good on these either because I mean either way, it's either it's insufficient because we don't have enough information, or we have sufficient information to say that it's bad. So either way, it's bad. It's just a matter of which one do we choose.
It's D. We got 100.
Oh, we did?
Yeah.
Good deal.
Easy enough.
Yeah, I'm just submitting it.
Yep, golden.
Yep.
Awesome.
I got 100.
Alrighty. I will submit this broadcast. I will talk to you guys next Monday.
No problem, man. You guys have a good night.
You
You
too.
too.
All right. Bye.
Bye.